Hello friends, let us discuss about basic requirements of a good combustion chamber. So we are going to discuss about the basic requirements of a good combustion chamber. Basic requirements of a good combustion chamber. And these requirements are as follows. First, high power output. Second, high thermal efficiency. Third, smooth engine operation. And fourth, reduced exhaust emissions. Now let us discuss one by one these particular requirements. So first, let us discuss about the high power output. So basically, whenever you design a combustion chamber, we expect that the power output from that particular combustion chamber or the engine should be higher. And in order to achieve this, first thing what we need to do is to increase the compression ratio, because we know higher the compression ratio, higher is the output of the engine. But the problem with the increasing in the compression ratio in case of preferably SI engines is that when we try to increase the compression ratio, up to certain extent it is okay, but beyond a certain compression ratio, which is according to that design of that particular combustion chamber, the engine starts knocking. So the compression ratio is limited by the knocking tendency of the engine. That is, knocking starts beyond a certain compression ratio if it is used in that particular type of combustion chamber. And therefore, that is where the term highest useful compression ratio comes into picture. That is, we generally use a particular standard type of engines in which we slowly go on increasing the compression ratio and check at what compression ratio that particular fuel and that particular standard engine is going to start. So that is where the highest useful compression ratio of the fuels comes into picture. Similarly, we need to test similarly the combustion chambers also regarding when that particular combustion chamber is going to start. That is, at what value of compression ratio. And basically the design of the combustion chamber is going to govern when which compression ratio is the maximum compression ratio which can be used without knocking in case of SI engines. Any change in the design or some improvements here and there can be done, but that has to be identified and done, which will result in increasing the output of the engine, and in turn it will result in increasing the efficiency of the engine. So the basic thing is there is a limit for using higher compression ratio for increasing the output in case of SI engines. Now, second parameter which is of importance is to use proper utilization of air and fuel. That is, whatever air what has been introduced into the combustion chamber, that need to be utilized, because we have introduced that particular air and we have compressed that air, that some work has been done on that air to increase its temperature. And if that particular air, that is oxygen in the air, is going unutilized, that much work is lost. In other words, the air is not being utilized properly. Similarly, if any unburned hydrocarbon is coming out of the engine, then it is also improper utilization of the fuel. So we have to ensure while designing the combustion chamber that whatever air and whatever fuel that has been introduced into the combustion chamber is going to be utilized properly. Now, in order to ensure this, preferably in case of utilization of air, we have to ensure that there are no dead pockets So the absence of the dead pockets, that is, what are these dead pockets? Dead pockets are that region where the fuel mixture is present, but it is unable to burn due to some reasons. The reason may be the mixture is unable to reach self-ignition temperature. Reason may be there is no availability of oxygen, proper oxygen for the fuel to burn in that region, or maybe the fuel in that particular region is going to burn in the last stage, that is the afterburning stage in the combustion chamber. So even if it is burned, but if it is burning in the last stage, that is afterburning stage of combustion chamber, it is not going to contribute into the power output, and therefore the whatever burning is going to take place, whatever burning of the fuel is going to take place, that has to be ensured in the second stage of the combustion in case of SI engine, which we call as flame propagation stage. So the absence of the dead pockets, or there should not be any dead pockets in case of SI engine combustion chamber, is one of the requirement. Now, next point, what need to be taken care is there should be optimum turbulence. So all these we are discussing with the respect to higher output. So we want to have optimum turbulence. Now, why we are here talking of optimum turbulence? Because we know that when the turbulence is increasing, the flame speed is going to increase. That means to some extent it is okay, but beyond, if it is going to increase, then the end mixture, which is getting compressed due to your main flame, if the turbulence in that particular mixture is higher, then it is easily able to reach self-ignition temperature. That is, knocking is going to be result. So we have to ensure here that the turbulence has to be there, but it should not be very high. So that is where we are saying it as optimum turbulence has to be there in case of combustion of SI engine. So that is again a requirement to ensure that proper combustion chamber design has to be used, which will result in optimum degree of turbulence. So in order to ensure this to happen, the air motion inside the combustion chamber has to be in a controlled manner, and when this air motion is controlled with the proper design of the combustion chamber, we are able to control the turbulence. So the optimum turbulence is the requirement in case of SI engine. Now let us discuss the second, that is for high thermal efficiency. Requirements for high thermal efficiency. So
in order to achieve the high thermal efficiency, the volumetric efficiency, basically the volumetric efficiency has to be higher. So if you are able to increase the volumetric efficiency, then more power is going to be produced. That is one way. Second is to increase the compression ratio. Increase the compression ratio. So that is one method of increasing the thermal efficiency. So if we increase the compression ratio, already we know that the turbulence is going to increase and the power output is going to increase, and when the power output is going to increase, the efficiency is going to increase, because thermal efficiency is whatever power we are going to get out of the engine divided by that is output upon input, and input is the fuel energy. So for keeping the same amount of fuel as the input, if we are able to get more output, then our thermal efficiency is going to increase. So one method of increasing thermal efficiency is to increase the compression ratio. Second is to use small heat loss type of combustion chamber, that is lesser heat loss. So anything which results in a lesser heat loss from the combustion chamber will result in increase in the thermal efficiency. How? Lesser is the heat loss from the combustion chamber, higher is going to be the heat retained inside the combustion chamber. Why we have introduced this heat into the combustion chamber? Because we want to increase the output. That is, we want to convert this particular heat into work output. Now, if this particular heat is lost to the combustion chamber wall, then the output whatever we are going to get will be lesser. Therefore, what we have to do is we have to ensure that lesser amount of heat is lost from the combustion chamber to the walls. So lesser the loss of heat from the combustion chamber, more will be heat retained inside the combustion chamber, and more the heat retained, more will be the output. That is, work heat converted into work has to be more. So that has to be our aim. So in order to ensure that heat loss is going to be minimum, what we have to do is to ensure that the surface to volume ratio of the combustion chamber has to be kept minimum. That is, for a given volume, the surface area of the combustion chamber has to be smaller. In other words, we say we want to have a compact type of combustion chamber. So when the compact combustion chambers are there, then the heat lost will be lesser, and that will result in increasing in the power output. In other words, it is going to increase in the thermal efficiency of the engine. Now, one more point what we need to take care here is a better scavenging of the exhaust gases. So if we are able to keep the exhaust gases out, that is means we are able to remove the exhaust gases from the combustion chamber in a better manner, then next time when we are filling the combustion chamber, we will be able to fill it with more amount of new mixture. And if you are able to fill with a more amount of new mixture, then we will be able to produce more work from every cycle. So from the every cycle, as a what we get as a final product, it is the exhaust gases. So unless we are emptying it completely, we will not be able to fill it properly. And what is the process for emptying this combustion chamber is called as? It is called as scavenging. So one of the important requirement for increasing the efficiency is good scavenging. That is, we should be able to remove all the exhaust gases which are produced as a product of combustion from the earlier cycle before we start the next cycle, so that in the next cycle we are able to completely fill the combustion chamber. thereby we are able to produce more work output. So that becomes another requirement where we are able to ensure that we are able to produce more output. Now the third requirement of the combustion chamber is smooth engine operation. Smooth engine operation. So in order to ensure that engine runs smoothly, something has to be done. And what is it? We have to ensure that the rate of pressure rise in the combustion chamber is moderate. Now why it is important in case of SI engine? It is important in case of SI engine because we know that in SI engines we have a homogeneous mixture, and since the mixture is homogeneous, when we strike a spark with the help of a spark plug and a flame is being produced, the flame will very easily travel throughout the combustion chamber in a very smooth, in a very fast manner. So if this is happening very fastly, then the rate of pressure rise will be high, and higher the rate of pressure rise. So if the end mixture is going to have the mixture is able to burn very fastly and produce a flame fastly, then one main flame and one secondary flame will collide and knocking is going to happen. So it is very essential that the rate of pressure, that is rate of pressure rise, has to be moderate in case of combustion chambers, preferably in case of SI engines, because though the pressure is a desirable thing in the combustion chamber to push the the piston downwards in order to produce work, the rate of pressure rise has to be moderate. That is, per unit time, whatever pressure is increasing, that has to be kept in the limit. And that is where we say, if that is when the rate of pressure rise is proper as per our design, as per our requirement, then we say the engine is going to run smoothly. If the rate of pressure rise is higher, the sound produced is more, and that we say that is what we say, the engine runs rough. That is, the firing is not proper as per our requirement. So in order to ensure that engine runs smoothly, we have to ensure a moderate rate of pressure rise during the combustion. Now, in other words, there should not be any knocking. So the absence of the knocking is absence of knocking, because the knocking is where we say there is huge noise. And if you want to ensure the engine is going to run smoothly, then you have to ensure that the knocking is not happening in the combustion chamber. Then second thing to ensure the smooth engine operation is again coming to the compact combustion chamber, compact size of combustion chamber. Now, what is this compact size of the combustion chamber? Because if the size of the combustion chamber is compact, then the flame will not be required to travel for a longer distance. And when the flame is not required to travel for a longer distance, then the end mixture will not be required to, that is getting compressed. So if the end mixture is not getting compressed more, then the probability of end mixture producing a secondary spark will be less. So if secondary spark is not going to produce, then the noise which is going to be produced due to knocking is going to reduce. That means if the size of the combustion chamber, the shape of the combustion chamber is such that the flame has to travel only very smaller distance while traveling in the combustion chamber, then the probability of producing sound due to knocking is going to be reduced. So that is where we have to ensure that the size of the engine has to be compact. So compact size or the compact combustion chambers will ensure that the engine is going to run smoothly. Moreover, the dead pockets, wherever possibility is there, because the dead pockets are the region where the fuel is going to burn after they are supposed to burn, and they may result in some unwanted things, and it has to be prevented. So all this, the dead pockets, so the combustion chamber design should be such that the dead pockets are not present in the combustion chamber. It has to be avoided as far as possible. Then next thing is proper location of the spark plug. So the spark plug location inside the combustion chamber has to be proper. Now what this means? This means that whenever you locate the spark plug, if you are locating the spark plug at one end of the combustion chamber, then the probability of, or the length required to travel for the flame in the combustion chamber is going to higher. That is, from one end where the spark plug is located to the other end of the combustion chamber. On the contrary, if you are going to locate the spark plug at the center of the combustion chamber, then the flame is going to travel towards all directions from the center, which in other words, we are going to reduce the flame travel distance. So one method of reducing the flame travel distance is to locate the spark plug in such a place in the combustion chamber such that the flame has to travel very less towards all sides during the travel in the second stage, that is flame propagation stage. And if this is done, the probability of knocking is going to reduce. In other words, the sound that is supposed to be produced due to knocking is going to be reduced, or in other words, we say we are going to ensure that the smooth engine operation is going to be ensured. Now this again has to be done with something related to location of valves. So the location of valves, similar to the location of the spark plug, is also going to play some role, because suppose we have the inlet coming from one end of the combustion chamber and the exhaust going from the other end of the combustion chamber, then we can see that the mixture has to travel in such a manner that the flame travel distance is going to be longer. So the location of the valves, preferably the exhaust valve, is going to play a very role in ensuring that ensuring that the operation of the engine is going to be smoother, because the flame, if it is going to be produced, if is such that is where to locate this particular valve, that has to be according to the design requirement. So there are certain regions in the combustion chamber according to where we say this is the location where which is the most suitable for locating the spark plug. This is the location where we say the inlet valve is supposed to be the best location for the inlet valve. This is the location for the best location for the exhaust valve. Like that, we have some requirements in the combustion chamber depending on what is happening in which region of the combustion chamber, and we have to take care that the valves has to be located in such a place where the probability of knocking is going to be reduced, because the temperature of the exhaust valve is going to be higher, and if these valves are going to be located in a region where the cooling probability is minimum, then the valves are going to run hot and they may start a new flame. So that is where the location of the valves becomes important. So the location of the valve, similar to the location of the spark plug, is also important in deciding the smooth operation of the engine. Then the next requirement is the satisfactory cooling. That is, cooling has to be proper. So whatever cooling provided preferably for spark plugs and valves, these are the more important parts which are the probable reasons for pre-ignition. So because if the spark plug is unable to cool, then the hot spark plug may remain hot enough to the in the next cycle also, and it may act as a nucleus for burning the mixture before your spark is going to burn, and this will result in pre-ignition. So, and the pre-ignition results in knocking. So that is where the cooling of the valves, preferably exhaust valves and the spark plug, becomes a very important parameter in reducing the noise due to knocking. That is initially knocking and then the noise due to knocking. So if you want to have a smoother engine operation, then the cooling provision for the spark plugs and the exhaust valves preferably is very important. Now moving ahead to the fourth parameter, that is reduced exhaust emissions. So in order to ensure that we are going to get reduced exhaust emission, in other words, we say we want to ensure that all the fuel and all the air which has been introduced into the combustion chamber is going to burn in a manner what we are going to expect. So now for that, whatever has to be done, obviously the combustion chamber is going to play an important role, because if the design of the engine is proper, then the fuel and air is going to properly utilize, all the fuel is going to burn, and the probability of formation of the exhaust are going to avoided. For example, if you take the formation of the nitrogen oxide, what are the important parameters which are going to result in the formation of the nitrogen oxide? Preferably, the parameters which enhance the formation of nitrogen oxide emission are the availability of oxygen, the more residence time of the burning gases inside the combustion chamber, and higher temperature. These are the parameters which are going to promote the formation of nitrogen oxide in the combustion chamber. So while designing the combustion chamber, we have to ensure that the gas is not going to be retained in the combustion chamber for a longer time. That residence time of the mixture of burning gases is going to be reduced first. Second, availability of oxygen. If the oxygen availability is more, then the probability of nitrogen formation is going to be more. That means we have to ensure that the very lean mixture is not being used. Why? Because more the leaner the mixture, the availability of oxygen will be more, and more oxygen is there, the probability of formation of the nitrogen oxide is going to be more. Similarly, higher temperature. So the very high temperature in the combustion chamber promotes the formation of nitrogen oxides. That means we have to design the combustion chamber in such a manner that nowhere in the combustion chamber the temperature goes beyond a certain limit. Because if you are allowing some part of the combustion chamber to go beyond a certain limit, then that region acts as a region where the nitrogen oxide formation is going to start. So that is how this is with respect to nitrogen oxide. Similarly, whatever is going to be promoting the formation of the pollutants has to be taken care when we design the combustion chamber in case of SI engines. So we have to ensure that then any of this thing is not going to happen. So if something is going to lead to pollution, then that has to be avoided. For example, we know the exhaust gas recirculation. If exhaust gas recirculation is going to happen, then the nitrogen oxide formation is going to be retarded. So if we allow some mixture going to be retained in such a manner that it is going to mix properly in the combustion chamber in the next cycle, then we can ensure that the nitrogen oxide emissions are going to be reduced. So all this requirements has to be taken care, and we have to ensure that the burning is going to be happen in such a manner that the exhaust emissions are going to be minimum. So for ensuring that the exhaust pollutions are going to be less, then the proper design of the combustion chamber that produces a faster burning rate of the fuel is essential. So the burning rate has to be proper. That is, if the burning rate is proper, then we can ensure that all the fuel is going to burn. So a faster burning chamber with a shorter burning time permits the operation with substantially higher amount of exhaust gas recirculation. So if the hydrocarbons are going to be retained, that is remaining inside, that is means there should not be any dead pockets, because if some dead pockets are there, then some hydrocarbons are going to remain in the combustion chamber without burning, and along with the exhaust they may come out. So all such probabilities has to be taken care while designing a proper combustion chamber in case of SI engines. So summarizing, what are the basic requirements of a good combustion chamber in case of SI engine? That is preferably the high power output, high thermal efficiency, smoother engine operation, and reduced exhaust emissions. These are the basic requirements of a combustion chamber. And to reduce to increase the power output of an engine, we have to ensure that the compression ratio is higher. Then all the fuel and air, whatever has been introduced, is going to be burned. That is, proper utilization of the air is going to be ensured. Then there is no dead pockets, optimum turbulence is there, volumetric efficiency is going to maximum. All this will result in increasing the power output of the engine. Similarly, higher thermal efficiency can be ensured by increasing the compression ratio, ensuring that lesser heat losses are there, and the scavenging is properly ensured in case of combustion chamber. Then the smooth engine operation can be ensured by designing the combustion chamber with the absence of knocking. That is, and for that, compact size of the combustion chambers are required, proper location of the spark plug, proper location of the valves, and proper cooling provision in the combustion chamber, preferably in the region where spark plugs and the exhaust valves are located.